plot analysis of two sets of data of bus times versus car times and driving to school. So Emma and Daniel are surveying the times it takes for students to arrive at school from home. There are two main groups of commuters who were in the survey. There were those who drove their own cars to school, and there were those who took the school bus. Emma and Daniel collected the following data. So the data is in minutes. So for example, bus times, someone took 14 minutes, 18 minutes, so on. And then you have your car times. So what I would like you to do is go to your calculator, your graphing calculator, and you're going to go to Stat, Edit, and you're going to put the two sets of data in List 1 and List 2. I put the bus in List 1 and the cars in List 2, so it'd be great if you would do that so we all have the same data. And then what you're going to do is Stat, Calc, and you're going to do a 1-bar stat after you do that for List 1, and then you're going to do Stat, Calc, a 1-bar stat for List 2. To change your lists, the lists are above the numbers. So if you want number 4, you're going to do second, List 4. So this would be second 2, List 2. So after you have done that, I want you to pause the video. And once you've run your 1-bar stats, I want you to calculate these measures and fill them in. So go ahead and pause the video and do that. Okay, so I have my 1-bar stats for list by bus 1 and my bus and my car. And just to find the mid-range on here, let me move this over a little bit, sorry. To find the mid-range over here, all I did to find the mid-range was add the low plus high, which you're given on the 1-bar stats, divide by 2. The range is high minus low, and then variance is not given on your 1-bar stats. So what I did is I found the standard deviation, and I'm using the sample one because this is a sample of times it takes to get to school. That's not all the times it took everyone to get to school at the school. So that's a sample. So I took my sample standard deviation and I squared it in both of the sets. So there's my 1-bar stats. Now we're going to look at the data by looking at the measures of central tendency and standard deviation. So if we take a look at the mean for the bus times is much, much longer than the mean for the car times. The median is much longer. The mode is much higher. So overall, it's looking like all 3 measures of central tendency are giving you higher bus times for getting to school than car times. If we look at even the range of the data, it's much larger for bus. So they're much more variable and it takes much longer. So if we look at the standard deviation of this is twice as big as that standard deviation. That means that on average, it takes almost twice as long from the mean to get to school using the bus. Okay, so we're going to create a little text box here, and we're going to type what we just said. So all 3 measures of central tendency, do that, so, sorry, my new touchpad. So all 3 measures of central tendency, that's your mean, median, and mode, and mid-range. I didn't include mid-range, but all 4. We can include all 4, sorry. Are larger for bus times than car times. So basically what we're saying here is that it takes, on average, longer to get to school by bus than car. Okay, that's the measures of central tendency. Now let's talk about the variability. We look at this, the range is bigger, and like I said, the standard deviation is twice as long. So let's say, I don't know why my pen color changed, but we'll change it back. Okay. Oh, well, we'll leave it black. The measures of variability, or you can call that also dispersion, it's also called, are larger or bus times than car. Okay. The standard deviation is twice as large or bus times bus riders and car riders. Okay, so both the range and the standard deviation are bigger. The range is also, let's say, 11 minutes larger or bus than car. Alrighty, so now it says, next question. By looking at the mean and the median, estimate the shape of each of the data sets. Okay, so let's look at this. So the mean of the bus is 18.8, and the median is 17.7. This one is a little bit bigger. So if we look at that, we're looking at that. This seems to be more symmetric because the mean, median, and mode are all almost around the same place. This would be a slight skew to the right because this is bigger. But on this one, the 18.8 and the 17, it seems like the mean is being pulled by something up, and then the mode is also 18. So the halfway point is at 17 there. So I'm going to look at that. If I look at the bus times, I'm going to do a little writing here. Okay, so on my, let's see. Okay, so I'm going to say for my bus times, the mean was 18.8, 18.8, and the median was 17. So that's looking like, and the mode is 18. So it looks like it peaks there. And then, so the mean is being pulled. When your mean is bigger than your median, you have a little bit of a right skew, because if it's symmetric, they're all three in the same place. So here was my mode, here's my median, and then the mean is here. So that means when the mean is being pulled, you have a little bit of a skew. So since this is larger than this, it is a right skew or a positive skew. Over here, though, we have the car times. And for the car times, the mean was 11.5, the median was 11, and so was the mode. So if you look at it, the mode is going to be the highest point, and then it's going to be a wee little bit of a skew because this is 11.5, but here's your mode and median at the same place. So, and one's also at 10 too. So this one is, if you look at this, I think it's bimodal because you have a 10 and an 11. Okay, so this one is going to be a right skew. And this one is going to be, we'll say mostly symmetric, and it may be a slight right skew. Okay, next one. Calculate the 5-number summary and graph the box plot. So let's do it on the calculator first, and then we'll take some time to transfer that over to paper. Okay, so to calculate it on the box plots, if you have a problem ever graphing them on the graphing calculator, all you have to do is hit Stat, Edit, Enter, and then you have your numbers already in your list, so you can hit Stat, Calc, oops, sorry about that. And then when you do 1-bar stats for each list, it gives you the 5-number summary that you need for your box plots. There's your 5 numbers for your box plots right there. So it gives it to you if you ever get stuck. All right, so let's do graphing box plots. So you're going to hit second y equals, and that gives you your stat plots. And you're going to go into plot 1 and turn it on. So you go into enter, and then arrow down, and then arrow right until you get to this box plot. That box plot automatically does outliers for you. This is the next one right here is your basic box plot, but we're going to do this one that automatically calculates the outliers for you. Okay, so I'm going to graph list 1, keep your frequency at 1 all the time, and then we're going to go back up to list plot 2. We're going to turn it on, do the same box plot with the outliers here. This is called a modify box plot. And then make sure you change it to list 2. Remember to change it to list 2 by doing second 2, and that'll give you your list 2. Okay, so once you have that, you're going to go up to zoom. So I can quit out of that. You're going to hit zoom, and then 9 zooms it into your statistics that you have. So once you hit zoom 9, there's your 2 lists. If you have the same exact box plot graphed twice, which is a common mistake that people make when they start, that means you're graphing list 1 twice. Go back in and check to make sure that you have plot 1 on list 1 and plot 2 on list 2. So that's a common mistake that people make. Okay, so we're going to go to zoom 9, and you can get your 5-number summary from either your 1var stats and get the 5-number summary from there, or you can get it from hitting trace on here. So if I hit trace and go left to right, and then if I go down, I can go to my other graph and go left to right, and that gives you your 5-number summary. Now we're going to transfer that over, move this back over, we're going to transfer the graphs over to a number line. So what I did for the number line is I looked at the min on one graph, and I went over here and I looked at the max on the other. The max on that first one, on that blue one, is 32. So I decided to make a number line from 5 to 40. So what I'm going to do now is I'm going to actually just hit trace, and I'm going to go through and I'm going to graph these 5 numbers. So I'm going to graph 12 through 32, and then on this one, I'm going to graph 8 through 17. So take a minute and pause the video, and you're just going to transfer. I'm going to keep my video running, but you can do that on your own paper, and then we're going to transfer it. Okay, so I'm over here. So we have, I'm going to do my first one, which is 12, which is a dot, and then 15. It's my Q1, and then 17, and then 22, and then 32. Okay, so there is my, well, I could have made that a little bit better, but there is my bus times, how long it took people by the bus. And then I always want to label my 5-number summary too. So 12, 15, 17, 22, and 32. For my car times, I'm going to go down here, and my lowest car time over here, if I look at the graphing thing calculator and go down, is 8, and then I'm going to just trace across to get my 5-number summary for that. And so I have 8, and then 10, 11, 13, and 17. Okay, so there's my box and whisker plot for my car times. All right, so we can see that when we said before, when we estimated our bus and car, look, this is much less variable than this. This box plot has a range of twice as much almost as this box plot. Let me label my 5-number summary: 8, 10, 11, 13, and 17. All right, now we're going to analyze the box plots. So I'm going to talk about it first, and then we'll type up the answer down here in a text box. Okay, so one thing we talked about is that the variability is twice as much from the car to the bus. The other thing that we talked about is the means and median. So look at where your median is here and your median here. All right, so one of the things that I want to talk about is percentages. Each piece of a box plot is 25%. So that's 25% of the data is here, 25, 25, 25. So one of the biggest things that I see when I'm looking at this is this right here. Let me change this to a highlight, sorry. Okay, right here, this line right here, that is lining up 100% of the car riders, all of the graph, 100%. 100% of the car riders took less time than 50% of the bus. So 50% of the kids that rode the bus took longer than everybody that took a car. That's kind of an important thing that you want to say. All right. Or you could say it the other way, 100% of the car riders took less time than the bus, or 50% took more than 100% of the car. Okay, so that's one thing that we want to say. Another thing that we want to look at maybe is this line right here. All right, or maybe this line right here. Okay, so if you see this, 50% of the car riders took 11 minutes or less, where 100% of bus riders took more. Let me mark that. So let's see, let me change it to a green here. So do you see this right here? So 50% of car riders took 11 minutes or less, and 100% of the bus riders took 12 minutes or more. So that's just further proof that the car riders took a lot less time than the bus riders. All right, so when you're writing your box plot analysis, I want to hear things like 50, 25, 100, 75%. So I want comparisons of where those things line up. Okay, so let's say this in a text box now. Text box bigger. Okay, so the first thing that we said was 50% of the bus riders took more time to get to school than 100% of the car riders. Right? Or you could say it the other way around, same thing, or 100%. Oopsie. Hit. Uh-oh. Fix that. Okay, 100%. I must have hit Control Paste there for a second. 100% of the car riders take less time, less than 50% of the bus. It's the same thing, you're just saying it one way or the other. All right, and then the other thing that I noticed is 100% of the bus riders take, and we said up here, 100% of the bus riders take 12 or more, where 50% of the car riders take 11 or less. And I should probably put numbers in there, but okay, so let me go back to my text box. Okay, so 100% of the bus riders take 12 or more minutes. And 50% of the car riders take less than 11 minutes. Okay, I probably should put some numbers in here. Take, and I should probably say something like take more than 17, and this is also 17. Okay, and then you could also say this one, or just the opposite way. You could also say something about the 75% also. So if we go back up here, 75, I can say something about this right here too. So let me draw. Let me do a little drawing. Let's use black. So do you see this right here? This is another thing you could also say. Do you see this 13? So you could say that 75% of car riders take 13 minutes or less, where 75% of bus riders take 14 or more. So this 75 is lower than at least the 75. You can't say 100 because you have some 12 down there, but you can say at least 75. So let's just add that one on too so we have all of them. Okay. So for the last sentence, I'm going to say 75% of car riders took less than, let's say 13 minutes or less, took 13 minutes or less, that's a Q3, while 75% of the bus riders took 15 minutes or more. So of course, so in conclusion, I don't know why that changes that color when I do that. In conclusion, bus riders have a longer commute to school. And that's it. That is our analysis of bus times.